All right, so last section we're going to look at is 2.3. And this covers the two other operations we can do with inequalities. So in homework, you looked at adding a number to both sides, and then we looked at subtracting a number from both sides. Today, we're going to do multiplication and division. But what I want to do is just kind of remember what the multiplication property means when we do it with an equation, because it's going to be very similar with an inequality. So if I had something like this, x divided by 2 equals 10. What would you have to do on both sides there to get x by itself? Anna? Times both sides by 2. So what she just said is the multiplication property for an equation. We're doing it for an inequality today, but it's almost the same thing. So this is just a reminder, you don't have to write this down. But when we're dealing with equations, the multiplication property of equality allows you to multiply both sides of an equation by the same number. Yep, you're welcome. Again, you don't have to write that down. Just a reminder of what it is. With equations, you are allowed to multiply both sides by the same number. The only number you can't multiply both sides by is 0, because if you multiply by 0, then you wipe everything out. You can't do that. Okay, so that's the multiplication property that we used with equations last week and the week before. Now, we're going to take that same idea and we're going to extend it to an inequality. But before we do it, you might think, well, isn't it just the same thing? Well, if you can multiply both sides of an equation by the same number, couldn't you just multiply both sides of an inequality by the same number? Just multiply by 2 and you're done? It depends. Okay, so we're gonna look at something. So we're going to take some inequalities, and we're going to see what happens when we multiply or divide both sides by a number. Let's see if it works. So I think you guys already have this part filled in on your table. It says 3 is less than 4. Let's just start out with that example. Is that true? Are we starting with something that is true? 3 is less than 4. Yeah, okay, that's true. Let's multiply both sides by 5. So I want to do a times 5 and a times 5. Okay, Caleb, if I multiply 3 times 5, what do I get? 15. And if I multiply 4 times 5, Brady, what do I get?
4 times 5 would be
20. So what I did there is I multiplied both sides by 5. The question is it still true? Is 15 less than 20? Yeah, what do you think, guys? Yeah, 15 is still less than 20. So it looks like that was okay. We multiplied both sides by 5. We started with something that worked, and we still ended up with something that worked, that was true. So it was okay to multiply both sides by 5. Let's try that out. Let's try dividing each side by a number. All right, let's look at this. -4 is greater than -20. Now, remember, when you're dealing with negatives, if it's to the right, it's bigger. So is -4 on a number line to the right of -20? Okay. Yeah, -20 is way down to the left. So that's true. Yeah, that's fine. Let's divide each side by 2. And let's see if we still end up with something that is true. So Joe, if I divide -4 by 2, what do I get?
2.
Negative divided by a positive is a Negative. So,
-6.
well, wait, what did you say before?
-2.
Yeah, -2. And Emily, how about -20 divided by 2? Negative what? -10. All right, so we divided each side by 2. Is -2, whoops, I flipped that. I didn't mean to do that. So keep it the same way. Is -2 greater than -10? Yeah. So we divided both sides by 2, and we still ended up with something that worked. So notice the first one, we multiplied by a +5. The key here is it was positive. And the second time we divided, but we still used a positive. Let's try it with a negative. Okay, let's look at what I have first. -5 is less than -3. Is that true? Is -5 smaller than -3? Is it to the left of -3 on a number line? Sean, what do you think? Is that true? What? -5 is less than -3. Yeah, that's true. Okay, so we're starting with something that's true. And let's multiply each side by -1. Sophia, if I multiply this side by -1, what do I get? Sophia, I'm sorry. What do I get if I multiply the left side by -1? Yeah, you get 5. How about if you multiply the right side by -1? 3. So when we multiply both sides by -1, now we have 5 is less than 3. Is that true? No. So that time it didn't work. We multiplied both sides by the same number, but we ended up with something that wasn't true this time. And it has to do with this. It's because we multiplied both sides by a negative. Let's try a division line. So the last one is 18 is greater than -6. Mia, is that true? Is 18 bigger than -6? No? How come? I sure can help her out, Lexi. How come?
Well, no, it's 18 is greater than
Okay, why?
because 6 is a negative.
Yeah, the 6 has a negative. So a positive number is always bigger than a negative number. Always. So that's true. Okay, so we are starting off with something that's true. And I want to divide each side by -3 and see what happens. So Abby, what's 18 divided by -3?
6.
Careful.
-6.
-6. 18 divided by -3 is -6. And Tirza, what about -6 divided by -3?
Positive 2.
That's a +2. So when I divided each side by -3, I started off with something that was true. And I ended up with -6 is bigger than 2. Is that true? Lauren? No. Negative numbers are not bigger than positive numbers. So we ended up with something that was false. And again, the reason why is because we divided by a negative. So when we're working with inequalities, if we end up multiplying or dividing by a negative number, we have to be careful. Right? And I'm going to show you what we have to do. It is okay to do it, you can multiply and divide by a negative number. But to make it work, you're going to have to do something. Okay, and I'm going to write down what you have to do. All right. So again, this part, you guys can just read this, but hopefully kind of notice the pattern. If you multiply or divide each side by a positive, it worked fine. Multiplying and dividing each side by a positive, we ended up with something that was true. But when we multiplied or divided by a negative, we got something that was false. Okay, so we have to fix that so we don't get something that's false. And that's going to be the next thing we write down on the guided notes. So this is the multiplication property of inequality. So the first part says that multiplying both sides of an inequality by a positive number is fine. You can do that. Multiplying both sides of an inequality by a positive gives you something that's equivalent to what you started with. If you started with something that was true, it'll still be true. Positive numbers don't mess anything up. But if, and now this is the part you guys have to fill in on your guys' notes. If you multiply both sides by a negative, it will only work if you take the sign and you flip it around. That's how we can make it work. So if you multiply both sides of an inequality by a negative, you have to take the sign and flip it. Now, did we ever have to do that yesterday? When we added a number to both sides or we subtracted a number from both sides? Did we ever have a problem where I said you have to flip it? Caleb? No, we never did this yesterday. And that's because when you add or subtract, you never have to flip the inequality. Flipping only applies to multiplying and the next one. Yes?
Can I please use the bathroom?
Yeah, please hang on. Okay, does everybody have the part after the if about flipping the inequality? Okay. Now, what happened when we divided both sides of an inequality by a positive number? How did that work out? We divided both sides by a positive. Lexi? Yeah, that was fine. So the first part, you guys already have written down, says if you divide each side of an inequality by a positive number, you will get something equivalent to what you started with. If you started with something that was true, and you divide by positives, it will still be true. But we had a problem if we divided by what kind of number? Yeah?
Negative.
A negative. So, yeah, it's almost going to be exactly the same thing you just wrote for the other if. So on the right-hand side, where you guys have those 4 lines, you want to write down, if you divide both sides by a negative, to make that work, you have to flip the inequality. And unfortunately, if you forget to do that, it's not like something's going to pop out at you and it's going to be obvious that you forgot to flip it. If you forget to flip it, nothing is going to happen. Like, it's not like something's going to pop up and say you did something wrong. You just have to remember to flip it. So if you divide both sides by a negative, you have to take the sign and flip it. So as far as like the notes, the steps for what we have to do today, that's the only thing that was different from yesterday. Now we'll just practice some examples. So we'll do the first one together, and then I'll let you guys try one on your own. Okay. So same directions as yesterday. Solve and graph. So just to put this kind of like, in context, what we're doing, we're still doing SAM, but a lot of these steps aren't going to be in the problem. You will not have to do simplify in this problem. There's no parentheses, there's no like terms. You're not going to have to do adding and subtracting in this problem. We did that yesterday. The only thing that this problem is going to have is either multiplying or dividing. All right, so how about, Michael, do you see something I could do on both sides to get the x by itself?
Divide by 7.
Okay, so let's divide each side by 7. And Michael, what's 7 divided by 7?
0.
So if you had $7 to give to 7 people, everybody would get none?
Oh,
1, right. It cancels out, but not because it's 0, because it's 1. So 7 divided by 7 is 1. So now all we have is an x. And what about negative 56 divided by 7? You can use a calculator if you need to, but it is in the times tables. Yeah.
Negative 8.
That's a negative 8. So negative divided by positive is a negative, and 56 divided by 7 is 8. Okay, now I had a negative here, so should I flip this inequality? What do we say? Yeah? But I thought if we had a negative, we need to flip it. Yeah?
There's no negative on both sides. Well divided.
Right, you have to divide by a negative. It's not if you had a negative just in the problem somewhere randomly. It's did you divide both sides by a negative number? And the answer here is no. We divided by a positive 7, so don't do anything to the inequality. Leave it exactly the way it was. And that's your answer. And is that the way we like it set up? Yeah. We've got the letter, we've got the symbol, and we've got the number. If it's set up that way, what does this symbol tell us? About Finnegan, what does that symbol tell us?
That negative 8 is greater than x.
Well, in terms of my graph.
Please excuse this interruption. Thank you.
So in terms of my graph, what does this symbol tell me?
We're going left.
Yeah, it tells me which way to shade, but only if you set it up letter, symbol, and number. All right, so we know we're shading to the left. Let's put some numbers on here. Let's go by 2s. So 0. Actually, I need probably 0 over here. -2, -4, -6, -8. That's fine. So you can number it like that. And what number am I going to put a circle on? Michael? -8. And what kind of circle am I going to use? Kate? Not closed for this one. But how come? Here's a why is it the other one?
Because there's no line under the less than sign.
Yeah, there's no line under the less than. If you have the line under the less than, that's when you fill it in. No line, no fill. Okay? So if it's just a less than, it's an open circle. And Finnegan already told us we're going to shade to the left. So draw your arrow left. And that's it. So very, very similar to yesterday. Questions on that? Yeah. Any questions on that? All right. So 1b, you guys have that still on the front. So see if you can take a couple minutes and get x by itself in that one. All right. So let's take a look at this one. So negative 3x is greater than or equal to 21. First thing, does anybody see what operation we're going to have to use on both sides? Are we going to have to add, subtract, multiply, or divide? We got to figure that out first. Yep. Divide. Yep, we are going to have to divide. And what would we divide both sides by to get the x by itself? Yep, Joe. Well, if we divide by 3, then the only thing that would cancel are the 3s. We also want to cancel the negative. Well, if we change the number, then the 3s won't cancel. So we want the 3s to cancel, but we want the negative to cancel with it. Let's see. Negative 3. So when we divide by negative 3, that cancels the negatives and the 3. And we have to do it on this side. So Anaya, what's on the left side now? Left side of the inequality. X. And then on the right side? Careful, that's negative 7, right? Because it's a positive divided by a negative. So negative 7. And which way should my inequality point? Should I keep it the same? Or do I have to flip it? Correct?
So it's even towards the answer.
Right, we have to flip it because we divided both sides by a negative. So you don't do anything with the x and the negative 7. You just flip the inequality so it points to the left. Okay, so we get x is less than or equal to negative 7. All right, now to graph. So again, just number 3 numbers on your number line, 3 or 4, that's fine. I'll do negative 8, negative 7, negative 6. Okay, so this time, Natalie, what kind of circle am I going to use?
Closed circle.
Yep, closed circle. And where are we going to put it? On the negative 7. So closed circle on the negative 7. And how about just in the, what way are we going to shade?
Sorry, to the left.
To the left. Because the inequality will tell us which way to shade because it's set up letter, symbol, method. So shade to the left. And that's example 1. Any questions on that one? All right, so both of those were problems where we had to divide on each side. I'm going to have you guys try a couple where we have to multiply. Okay, so we'll try this one. We've got one more, and then we'll do the we'll do a word problem. Okay, see if you can get x by itself, and see when you're done if you can set it up properly. Don't worry about setting it up properly first. Just see if you can get x by itself. But then let's see if we can write the answer the way we like to write it. Look at this one. So we have 5 is less than x divided by 2. So is the x by itself? If it's already by itself, then there's nothing we have to do. So what do you think? Is the x by itself? Here's that? No. Abby, what's with the x that we don't want? The 2? And specifically, what are we doing with the 2? What operation? Right here?
Oh, the divide.
Right. What we're doing that we don't want to do is we're dividing by 2. We do not want to divide x by 2. We just want x. So how do you get rid of dividing by 2? Yeah.
You multiply by 2.
Multiplied by 2. Times 2. Times 2. On the right, when you divide something by 2 and then you multiply it by 2, those two things cancel each other out. Right? It's like adding 3 and then subtracting 3. Just brings you right back to the beginning where you started. So the 2's are gone. And on the left side, what do I get on the left, Alex?
What did you get on the left?
Ten. Yeah. 2 times 5 is 10. We still have the less than, and we still have the x. Now, why didn't I flip it? I multiplied each side by a number. Yeah?
Because you weren't multiplying it by, or dividing it by a negative.
Right, I didn't multiply or divide by a negative. I multiplied by a positive 2. So I did not have to flip the inequality at that step. Now, let's look at what we have here. 10 is less than x. Is that the way we like to set it up? Okay, Emily? No, how do we like to set it up? Yeah, we like to put the variable on the left. So we would rather have letter on the left and the number on the right, but it was pointing at the 10. So when we fix it, it still has to be doing that. Yep. Sure. So if it was pointing at the 10 to start, it still has to be pointing at the 10 when we fix it. And that is how you'd write your answer. So when we solve inequalities, there's 2 times you might flip it. One is if you multiply or divide by a negative. The other one is when you're fixing your answer to be in the right format. Those are 2 totally separate things. Okay? So I did not flip this because I multiplied or divided by a negative. I flipped it because I wanted to fix it so the letter was on the left. And again, that's something we talked about on Monday. So now that I fixed it, Brady, what does this inequality tell me?
So it's not.
In terms of my number line.
It would say that Are
Like,
you asking what
how does this help us draw the picture for this now? What does that inequality tell me?
Alright, so it would be a open circle on 10 with a arrow pointing to the left.
Not quite. That inequality
No. An arrow pointing to the right.
to the right.
That's right.
So this is pointing to the right. So now that tells me when I shade to the right. And I agree with everything else you said. It is an open circle. So let's just put down some numbers on my number line. Open circle on 10. Shade to the right. Any questions on? Okay, let's do this one together. Negative 2/3 x is greater than or equal to 12. This time we have a fraction in front of a letter. Does anyone remember, like, if this was an equation? We haven't used this in a little while, but we talked about it. Whenever you have a fraction next to a letter, what do you do on both sides? Yep.
Isn't it, it might be a flip change, but I think I'm thinking of the wrong thing.
All right. One of those words you said might be involved with what we have to do. Yeah?
I used the reciprocal.
Reciprocal, which means to flip, right? You take the number that's in front of the variable. Okay, Brady said use the reciprocal. But what do you mean use the reciprocal?
So you use the reciprocal and to get rid of 2 over 3, and you multiply.
Right, we want to multiply. So that's the key. we are going to multiply each side by something. And Brady said said the reciprocal. Can somebody else tell me what the reciprocal is for negative 2 over 3? Yeah? Yeah, 3 over negative 2. It's when you flip it. And do the same thing here. Times 3. So I multiplied by a 3, and I divided by a negative 2 on each side. That's going to cancel this number out on the left. Because you have a negative 2 in the top, negative 2 in the bottom, 3 in the top, 3 in the bottom. That cancels everything out. Now, we have to multiply by 3 and divide by negative 2. So what might I want to do right now so I don't forget? Something important. Well, what did we multiply both sides by? Okay. Yeah, what did we multiply both sides by? No, not 2. Lexi? The reciprocal, which was what? We multiplied both sides by 3 over negative 2. So what should I be doing? Kayla, can you tell us again, what did we multiply both sides by?
2/3. Wait.
Come on, guys, this is the fourth time I've asked the same thing. What did we multiply both sides by? Lexi, can you tell us for the third time? We multiplied both sides by 3 over negative 2. So what kind of number did we just multiply both sides by? Yeah?
Negative.
A negative. What are we supposed to do when we multiply both sides by a negative? It doesn't matter if it's a negative fraction or a negative decimal, it's still a negative. So, yeah? Right. We need to flip the inequality because we multiplied by 3 over negative 2. So we multiplied both sides by a negative number. Now we just have to do this out. What's 12 times 3? Yeah?
36.
36. So I'm just doing it off to the side. And now we have to finish that up. What's 36 divided by negative 2? Yeah? Negative 18. There you go. So just because it has a fraction, that doesn't change our rule. We still have to flip it because we multiplied by a negative. Oh, I didn't flip it. Yeah, sorry. I was so busy asking you what you multiplied by. Yes, you need to flip it. That was the whole point. So x is less than or equal to negative 18. Let's just put, let's go like this. Negative 17, negative 18. Close circle on negative 18. And we're going to shade to the left. Okay, so maybe the fraction just tripped people up a little on that, I'm not sure, but in multiplying by the reciprocal we hadn't done in a while. Okay, so last question. It says that you earn $9.50 an hour at your summer job. Write an inequality that represents the number of hours you need to work to buy a camera that costs $247. So you work at a job and you get paid $9.50 per hour. So how would you figure out the total amount of money that you make? What would you have to know? Like for the week. Like if I said, okay, I make $9.50 an hour, how much money am I going to make this week? Well, what do you have to know? Yeah?
How many hours a week you're actually working?
Yeah, you have to know how many hours you worked. So let's let H equal the number of hours worked. So how would you figure out how much money you made if you worked H hours and you made $9.50 every hour? Have a guess how it matters? Like if you worked at a job and you make $9.50 an hour and you worked for 5 hours, how would you figure out how much money you're going to take home? You multiply, right? You take how much money per hour times how many hours. So how would I write down in this problem if I work H hours and I make $9.50 an hour? $9.50 H. That's the amount of money that we make. And the amount of money we make would have to be what to be able to afford that camera? Dorian?
Greater than or equal to 247.
Right. The amount of money you make would have to be greater than or equal to 247 if you want to be able to buy that camera. So now all we have to do is solve that for H, and that'll tell us how many hours we have to work at a minimum. You could always work more if you wanted, but how many hours you'd have to work at a minimum to save up $247. So, Cadence, how would I solve that for H? Yeah. Divide each side by 9.5. Should I flip my inequality? What do you think? Finnegan? No, I didn't multiply or divide by a negative. I divided by a positive. So H is greater than or equal to, let's see how many hours we'd have to work. 247 divided by 9.5. So that would be definitely doable in 1 week. We'd have to work greater than or equal to 26 hours. Okay, so when you get to a word problem, try to think it out like if this was you and you actually wanted to do it. I think some people see a word problem and they just off, done. But sometimes it's, if you want to try and figure it out, I think a lot of you could. I really did. Okay, so homework tonight is worksheet on 2.3. Tomorrow we'll go over it. And then after that, we'll have the entire class to review for the test. Remember, I will be after school tomorrow. Progress reports come out on Friday. So if there's anything you need to make up, you've got to get it done by Friday. Okay, where I'm just going to fill in zeros for everything you don't have.